We're going to do some example calculations for simple harmonic motion. So mass on a spring is displaced 2.5 centimeters from equilibrium and released. Takes 0.32 seconds to return to equilibrium. Alright, we want to write the equation. I've got a bunch of questions that I could ask you here. Equation is position is a function of time, velocity is a function of time, acceleration is a function of time, maximum velocity, position at some time, distance traveled, velocity at some time. There are a few more different questions I could ask you. But first off, equation for position is a function of time. Well, we know that x is a cosine omega t, meaning that we need to find a, we need to find omega. A is easy. We're already given that it's displaced 2.5 centimeters and released, so this is our amplitude. So that's simple. Omega, in order to find omega, well, we know omega is 2 pi over t, so we need to find the period. It takes 0.32 seconds to return to equilibrium. So what's happening here? We're 2.5 centimeters from equilibrium. We go down, we reach equilibrium, and the sine wave looks like this. Going from here to here, that's half the time it would take to go from here to here, and from here to here is half the time it would take to go from down and back up again. So going from here to here is a quarter of the full period. So if it takes 0.32 seconds to return to equilibrium, our period is 0.32 times 4, which is 1.28 seconds. So our position as a function of time is 2.5 cosine of 2 pi over 1.28 t. And that would be our answer. Depending on what a problem says, you might need to convert that to meters. I didn't really specify. So if you do something like this, you should specify that that's in centimeters probably. But the important thing is being able to write that equation. And now we have what we need to write the velocity and acceleration equations as well. Velocity as a function of time is minus a omega sine omega t. So that's just, we have our a is 2.5, our omega is 2 pi over 1.28, and then we have sine 2 pi over 1.28 t. Alright. As a general rule, I think I would usually rather see something like a 2 pi over 0.28 than punching that into your calculator, or 2 pi over 1.28. I'd rather see that than punching it into your calculator and getting a decimal for it. Just so you know. And acceleration, again, we have an equation that we have all the pieces for. It's minus a omega squared cosine omega t, which is just minus 2.5, 2 pi over 1.28 squared cosine of 2 pi over 1.28 t. Very straightforward. Still, maximum velocity, also very straightforward. We know it's the maximum value of this function, and that happens when sine is 1. So our Vmax is just this coefficient out here, 2.5 times 2 pi over 1.28. In this case, since we're getting a velocity, since we're actually calculating a number, I would prefer a decimal, 2.5 times 2 pi over 1.28, which is about 12.27, whatever. And that, keep in mind that our 2.5 was in centimeters, so this would be centimeters per second. Here I want to make a point, x of 2.5 seconds. Well, I'm just plugging that into our equation here. That's 2.5 cosine 2 pi over 1.28 times 2.5. Whenever we're doing this, because this is circular motion, we need to be in radian mode. As we've said, our omega is 2 pi over t. I guess you could use degrees if you said 360 over t, but we're always going to stick with our 2 pi. So make sure you're in radian mode. I am in radian mode, good. And then we can punch this in, 2.5 cosine 2.5 times 2 pi over 1.28, and get that our position at 2.5 seconds is about 2.392, etc. centimeters. That's very straightforward. Now this gets a little bit trickier. Distance traveled after 1.3 seconds. Okay. Now why is this tricky? Well, because distance traveled, we can find our position at 1.3 by plugging in 1.3 to our x equation here, but that doesn't get us distance traveled. For example, if I said distance traveled at t equals, what did I say? Our period was 1.28. At 1.28 seconds, well, this would just be one period, which means we go up and down, and so our distance traveled, well, we go amplitude, 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 amplitude. So in one period, the distance traveled is 4 times the amplitude. So here we've got 4 times the amplitude plus some. 1.3 is just a little bit more than 1.28. So at x equals 1.3, our position is this, 2.5 cosine 1.3 times 2 pi over 1.28, which is about 2.4879, okay, which means that from the start of a period, we've gone 2.5 minus that. Minus that. And that's 0.01203 from our maximum displacement. However, before this, we've traveled one full period. So we've gone one period and then back down a little bit. Okay, we've gone back down this much. In that one period, we've traveled 4 times the amplitude. It's 4 times 2.5, which is 10 centimeters. So then our total distance traveled is 10 plus is 0.021, and so the total distance traveled is 10.012. Oops, I put an extra 0 in there. Sorry, 10.012 centimeters. So getting distance traveled is a little bit more complicated than the other stuff. And this is just a straightforward velocity at 0.56 just means we plug 0.56 into our velocity equation. Minus 2.5 times 2 pi over 1.28 sine 2 pi over 1.28 times 0.56. And we can punch that into the calculator very simply. 2.5 times 2 pi over 1.28 sine 0.56 times 2 pi over 1.28, and get that our velocity at that time is minus 7.694 centimeters per second. So again, all of these are very straightforward. Distance traveled can be a little bit tricky because there isn't really a formula for it per se, but you have to figure out how many periods you've gone, and you can work it out from there using some of your reasoning skills. Taking another example here, say you've got an apple in the water and it bobs up and down with a period of 1.1 seconds. At t equals 0.13 seconds, the apple is at y equals 0.35 centimeters. Since it's going up and down, I'm using y instead of x here. I don't know, what is the amplitude? Well, what we're given is that at t equals 1.13, the apple is at 0.35 centimeters. Since we're vertical, we can say y equals a cosine omega t, and remember omega is 2 pi over period. So 0.35 equals, just plugging into our equation, a cosine of 2 pi over 1.1 times 1.3. And we can solve for our amplitude by working backwards through this equation. 0.35 divided by cosine of 1.3 times 2 pi over 1.6. 1.1. I can't read my own handwriting. And that comes out to an amplitude of 0.842. And since this 0.35 was in centimeters, then our amplitude is 0.8425 centimeters. Once we have that, we have everything we need to write the equations, and so we could figure out any number of things, any of the things I asked in the last example. But what I have here is, what is maximum velocity? Well, we know that V max is a omega, so that's 0.8425 whatever, times 2 pi over 1.1. I'm going to store that as a times 2 pi over 1.1, and we get 4.8125 centimeters per second. And acceleration is a function of time. We know acceleration as a function of time is minus a omega squared cosine omega t, which in this case is minus 0.8425, etc., times omega 2 pi over 1.1 squared times cosine 2 pi over 1.1 t. And again, when you're writing out your equation, an equation that you would use to calculate stuff, I would rather you leave it as 2 pi over 1.1 than getting a decimal. Although for a we have to use a decimal because that's all we have. Yeah, so hopefully that gives you an idea of how we can solve simple harmonic motion problems. And once we have our amplitude and our angular frequency, then we can calculate really anything else we want to related to the simple harmonic motion.